Hi, this is Fredrik. A basic introduction to regression analysis, part 2. I will now give an example of how regression analysis is used. And what we're going to look at is the association between number of rows in the home of Swedes in a small city and the number of people in the household. So here I have made a scatter plot of the data. By looking at that, we see that there seems to be some kind of positive relationship in the sense that the more room, the more people in the household and vice versa. It is, however, important here to notice that the points here can be more than one observation. And we will use a simple regression analysis. So we're going to try to fit a straight line. Our model will be the number of rooms is equal to the intercept or A value plus the B value multiplied the number of individuals in the household. Y is room, X is individuals. And if we let R fit the data, we get this fitted models. And it says that the number of rooms is equal to 2.46 rooms plus 0.76 multiplied by the number of individuals in the household. And this is how the fitted straight line looks like. And we see here that the number of rooms for household without any members is 2.46, and this may look a little bit strange. But this is also a good example of that you need to think about what interval your model can be used. So the model we are using here can only be used for the range of number of people in the household for which we have data. So it starts with 1, and the largest household in the data set that is 7. 0.76 tells us how much on average the number of rooms increase if we go from 1-person household to 2-person household, or if we go from 3-person household to a 4-person household. The reason for why we get the same increase independent of the number of individuals is that we are fitted a straight line. If we compare 1-person household with a 3-person household, we have to multiply 0.76 with 2. If we want to compare a household with 4 people with a household with 6 persons, we have to do the same thing, 2 times 0.76. And want to compare a larger interval, for example, a household with 2 members and a household with 5 members, we have to multiply the B value 0.76 with 3. So regression analysis can be used for predicting. For example, if we have a person that we have no information about except that this person is from a 3-person's household, we can calculate the number of rooms the household have by multiply 0.76 with 3 and add 2.46, and then we will get 4.74 rooms. A 3-person's household will, according to our model, and it's important to remember this is what our models say, nothing else, they will in this city in Sweden have 4.74 rooms. In Sweden we have quite large houses and apartments compared to the rest of Europe. The person here that we didn't know anything about, he tells us that he have 3 rooms. So we will not always get the right value, and this is something that we'll come back to. We will have an error time between the prediction and the correct value for this person here. How do we then get the best fit for a regression line? most of the time, if you have not that many observations, you can get a quite good fit by doing it by hand. But the way standard regression analysis works is that we try to the line that minimize the distance between all observations. So here we have the distance between the line and all observation. But we can't just make a sum of them because they will even out to zero. And the reason for this is that the points above the line is positive and the observations or points below the line are negative. So what we do instead is that we take the square of all distances, because by this we avoid the negative value. We will only get positive values. Here we have some examples of when I have fitted the model with the drawer, and we can observe that we will get different values for the sum of squared errors. Here I have plotted different values for the b value. The best fit is where the red dot is. And that is 0.167. Now it's time for one of the examinations on this course. Your task is to determine by try and error which line that provides the best fit for two different data sets.